Hello everyone, and then welcome to another video. So in this video we'll be treating reduction of order, okay, in differential equations, okay, right. So for the topic reduction of order, we are trying to prove or produce a differential equation, okay, most definitely linearly homogeneous differential equation, okay, whenever you've been given one function, okay, maybe you've been given maybe y1 to be a certain expression, okay, and then you have to find what's y2, okay. So after that you add y1 to y2 in order to produce a homogeneous linearly differential equation, okay. So you are always given one function, okay, y1, and then you are given a specific expression to produce y2, and then you combine y1 and then y2 to produce a homogeneous differential equation. So let's see how we go about that, okay. So this is a general form of homogeneous differential equation, okay. So whenever you meet any question and then you are supposed to use the reduction of order, this is how the equation most of the times appear to look like, okay. So we have y prime prime, okay, and then plus p of x y prime, okay, plus q of x y, okay, and then we equate it to 0. It means that it's a homogeneous differential equation, okay. Now you are always given y1, always, okay, always given y1, okay. Keep that in mind. You are always given y1, okay, to be a specific expression, okay, y1 of x, and then you use this formula to get y2, okay. So we have y2 to be equal to y1, okay, huge differential, and then we have e minus another differential, okay, p of x, okay, and then we have dx, okay, all of this divided by y1 squared, and then we have dx, okay. So this is very important. This formula is very important, and just keep this in mind, okay. Keep this formula in mind. It's very important, okay. Now let's see how we try solving a particular question using the reduction of order method, okay. So first things first, all your homogeneous differential equation has to be in this format, okay. So the y prime prime must not have a coefficient attached to it, okay. Keep that in mind. It's very important, okay. The y prime prime coefficient has to be always equal to 1, okay, right. So let's see how we go by this. Let's solve an example, okay. So we are told to find the general solution, okay. You have to find the general solution to this form of homogeneous differential equation. So we have 2 y prime prime, okay. This actually 2x, okay. So let's see how we bring that back, okay. So we have 2x, okay, 2x y prime prime, okay, and then we have plus x y prime, okay, and we have minus 3y equal to 0, okay. Now let's see how we go by solving this question, okay. So we have our solution, okay. Now so let's rewrite the question, okay. So 2x prime y prime prime, xy prime, okay, and then we have minus 3y equals 0, okay. So this is equal to sine. Keep that in mind. Okay, now let's see how we go by this. Now, as I stated earlier, the coefficient for y prime prime has to be what? 1. Okay, so let's see how we go by that. Okay, so we divide throughout by what? 2x. Okay, we divide throughout by 2x. Okay, this is actually 2x squared. Okay, we divide throughout by what? 2x squared. So we have y prime prime equals what? X all over what? 2x squared. Okay, y prime minus 3 on 2x squared y equals to 0. Okay, so now we are trying to keep the y prime prime's coefficient as 1. Okay, so we divide throughout by what? 2x squared. Okay, so initially this was supposed to be 2x squared. Okay, so pardon me for that. That's supposed to be 2x squared. Right, so let's proceed. Okay, so now we could notice that we have our what? General formula. Okay, let me rewrite the general formula, then you get to know. So we have what? Px, okay, y prime, okay, and then we have what? Qx y to be equal to 0. So from here you can notice that p of x is what? X on 2x squared, and then q of x is what? 3 on what? 2x squared. So let's use the general formula. Okay, right, and then from the same question, okay, we were given y1, okay, y1 of x, okay, to be equal to x exponent minus 1. Okay, okay, so let's proceed. So we have y1 of x to be equal to what? X exponent minus 1. So we could find what? y2. Okay, we know that y2 is equal to what? y1. Okay, and then we have e exponent minus, and then we have another differential integral. Okay, p of x, okay, dx divided by what? y1 squared. Okay, dx. So let's insert our value. So we have what? y1 to what? Exponent minus 1. Then we take the differential. Okay, minus p of x is what? We have x on what? 2 on what? x squared. So we have x on 2x squared. Okay, dx. Okay, and then we divide the whole of that by what? y1 squared. So that's what? X minus 1 or what? Squared dx. Okay, yes, let's proceed. Now let's try simplify. Okay, right, so we have x exponent minus 1. Okay, right, so let's try do a simple what? Integration over here. Okay, so note when you integrate the whole of this, okay, when you integrate the whole of, okay, let me rewrite that. We have 2x squared dx. Okay, when you find the integral of the entire of this expression, okay, you end up with what? When you integrate this, okay, you end up with x minus 1 on 2. Okay, as I said earlier, I won't be going through all the integrals. Okay, you are already given the entire what shortcuts. Okay, so all you need to know is how to go by what the various what integrals. Okay, right, so we have x, okay, minus 1 on 2 divided by what? X. Okay, this is what? Minus 1 exponent 2, so this minus 2. Okay, keep that in mind. Okay, and then we have what? The x. Okay, so now let's try simplifying things further. Okay, we have y2. Okay, so let's try integrating this portion of the what? Differential. Okay, right, so from here, okay, let me just further simplify this. So from here we have what? x exponent minus 1 on 2, and then what? Divided by x exponent minus 2. So when you compute that, you end up with what? X exponent what? 3 on 2x, okay? Right, so after that you try integrating, okay? So when you integrate this, again, when you integrate this, you end up with what? 2 and 5, okay? And then we have x exponent 5 on 2, okay? Plus c, okay? This simple integration, okay? Simple integration means that we are adding 1 over here, okay? You add, okay, let me do that over here. So we have what? X exponent what? 3 on 2, okay? The x. So all you are doing is just add 1, okay, and divide by the entire expression. So we have, when you add 1 to this, okay, when you add 1 to 3 on 2, okay, you get what? 5 on 2, okay, and then you divide the same thing by what? The entire expression. That's how you're able to come by this, okay? Right, so let's proceed from there, okay? So now let's try simplify this further, okay? So once you try simplifying this further, you end up with what? 2 on what? 5, okay? And then we have s exponent 3 on 2, okay? Plus c, okay? So this will go with what? X exponent minus 1 will just add 2. We just add that to what? S exponent 5 on 2, and then we end up with this, okay? And then note that c has to be what? Equal to 0. So let's keep c to be equal to 0. So now our y2, okay, is equal to 2 on 5, okay, and then we have x exponent 3 on 2. So this is y2, and then we know that y1 is equal to what? Exponent minus 1. So in conclusion, we could just write the general what? The general formula, okay? The general formula which is y, okay, equals c1 y1, okay, plus c2 y2, okay? So once you try rewriting this, we have what? c1, and then we have what? y1 is what? X exponent what? Minus 1. Note that we are only writing out the what? The main expression, okay? We don't normally pay close attention to the coefficients, okay? And then we have what? C2, because these C's, okay, already represent coefficients, okay? And then we have what? X, okay, exponent 3 on 2. C2, C1 are coefficients, okay? So we don't bother ourselves rewriting the coefficients, okay? Right. So this is how you solve for what? Reduction of order, okay? This is how you go by solving reduction of order questions, okay? So let's take another what? Question, okay? And then we see how we go about that, okay? Okay, so let's take the second example. Right, so we have what? Question 2, okay? So we have to find what? The general solution for this question, okay? Right, so we have what? 4, okay? Y equals 0, and then we've been given what? Y1, okay? To be e exponent 2x. So let's see how we go by solving this, okay? Right, so we know our y2, okay? y2 is equal to what? y1, okay? And then we have that expression, okay? P of x dx, okay? And then divided by what? y1 squared dx. This is the most important formula you need to keep in mind. Now we know what our p of x, okay? This is our p of x, okay? So we have what? y2 is equal to what? Our y1, which is e exponent 2x, okay? And then we have that, and then we have what? Minus 4, okay? That's minus 4, x, okay, divided by y 1 squared. So we have what? E exponent 2x all squared, okay, and then we have what? The x, okay. Let's proceed. Okay, so we have y2 equals what? E exponent 2x, okay. Right, so when you integrate this, so we have what? Minus 4, that's what? Positive 4, okay. So when you integrate a constant, okay, when you integrate a constant, you end up with what? So when you integrate this, so we have what? Negative 4, so that's what? Positive 4, okay. So when you integrate a constant, you end up with what? Adding what? The variable, okay. And then you divide that by what? E exponent 2x multiplied by 2, so that's e exponent 4x, okay, dx, okay. So now let's proceed. So we have what? Y2 equals what? E exponent 2x. So when you integrate the whole of this, first this will cancel this, right? So we will be left with 1. So when you integrate a constant, as I stated earlier, you add the what? X, okay. So that will give us what? X. Then we have what? Plus c. Again, c has to be equal to what? 0. We don't need that right now, okay. So we have y2, okay, being equal to what? Our expression. So we have x, okay, and then you have e exponent 2x, okay. Right, so these are what? Solution. Then we write the general form of the what? Expression, okay, or homogeneous expression. So we have c1 y1 c2 y2, which is most definitely equal to c1 y1, which was what? E exponent 2x, okay, and then plus what? C2, which is what? Again, we don't write the what? Coefficients, okay, because c2 is already the coefficient, okay. But from here you can decide to keep the x, okay, because the x doesn't look much like a coefficient, okay. It's like part of the expression, okay, but it's better you just keep the coefficient out of the expression, okay. So we could just write c1 e exponent 2x, okay, plus c2 e exponent what? 2x, and then you are good to go, okay. Right, so thanks a lot for staying with me to the end of the video. Kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video. Like the video, kindly share, okay, kindly share the video, okay, to help support this channel, okay, and then leave your questions in the comment section, and then I will reply to them as soon as possible. Have a lovely day. Bye bye.